All right. Any questions? Okay, so let's look at put get and let's look at today's ODP. So here's a basic version of put get for ODP 419. So this is basically the prototype code that we put up yesterday without all of the details in it. Put just takes an argument and saves it in this global variable called saveval. Get just returns the value of that global variable. That's really the gist of it. But there's ways you can go wrong. For example, if you say integer saveval equals I, you defeat the whole idea of a global variable. Saveval becomes a local variable, and I copy I into that local variable, but the original integer saveval hasn't been changed. Or if down here I say something like integer saveval, right? That's making saveval a local variable with no particular value, and then when I return it, it returns the value of this local variable. And even if I try to do this, saveval is local, so it's this notion of scoping of variables. The compiler needs to decide what does saveval mean when I see it inside this function, and since it's declared to be a local variable, it means this saveval right here. We'll do something like this in Java where this will actually work, where we'll sort of pick up a global value and assign it to a local. But in C, it's just not that sophisticated. So you really just need something like this, one global variable. You have to say integer argument name up here because arguments need to have a type associated with them. But that's really the only place that integer appears other than the function returns. And I forgot to return 0, but you can return 0. So the next ODP is very similar, except you can save multiple values. So your put function has been augmented. It takes a first argument, which is sort of a memory location. So this is like on your calculator where you have 10 memory spots you can store numbers into. So you can say put, and that first argument can be anything between 0 and 9. And the second thing is the value you want to store in that memory slot. And then when you say get, you pass it a number, which is which memory slot do I want to get the value from, and it returns the value. And so this is almost exactly like ODP 419, except your global variable that you say values in is now an array. And your put function copies that second argument, the value, into whatever index in that array your first argument specifies. And your get function retrieves from that argument that index in your array. So it should look very similar to 419. All right, so questions on that?
Can you give an example of what output should look like?
What should look like?
When we run the ODP 420, what it should look like?
So if you say something like, well, let's make some test code. So there's some calls to put, right? I'm putting 55 into register 5, 111 into register 1, and 13760 into register 9. And then let's just call get inside a loop and print out the value of each of those registers. And so if I run it, register, I didn't go far enough. If we run it, register 1s, 5, and 9 contain the values that we put into them. The other ones happen to contain zeros. They could contain anything. If you don't put something in, we don't know what we're going to get. But those 3 registers contain those values. So that's just some sample code, but do more testing than that. Test all the locations, test location 0, and so on. All right, any other questions on anything? So that hopefully people don't come rushing up right after class and say, I've got some questions on things. This is a good time to talk about questions, because your questions are not unique. Right, I get the same questions from lots of different people. Good so far? Okay. You can always come up after class. So we were developing this superdupergetchar program yesterday. And so it was going to include C types, so we could use things like toUpper. So I think this is the version we left off with. Right, we're reading a character with regular getchar. If it was end of file, we returned end of file. Otherwise, we called toUpper to change it to an uppercase letter, and then we returned that value. And so there's a main program to test our getchar functions. So we'll get a character, and if it's not end of file, we'll print it out with a %C, so it should just look like a character, and we'll keep looping on this until we get end of file, and then we'll say goodbye. So here's a test file called file, and if I run go and I say read standard in from this file, it gives us this uppercase version of the input. Punctuation is unchanged, new lines are unchanged, but lowercase letters change into uppercase letters. So let's expand this, and let's deal with this white space issue. So the second requirement in the ODP is if you have any form of white space, new lines, tabs, vertical tabs, form feeds, carriage returns, they should all be turned into a space. So we've got C, we did C equals 2 upper C. So isSpace is a function we can use. It's in ctype.h, which tells us, is this character C some sort of space? And if it is, what does PA4 assignment say we should do? We should change it into a single space. So C equals a single space. Now we got 2 of our 3 things done. So if it's an end of file, we just return end of file. Otherwise, if it's a lowercase letter, it'll turn into an uppercase letter. If it happens to be any kind of space, new line, etc., it'll get changed into a plain old space.
What are the return values for isSpace?
It returns something that works inside if. So the values returned are non-zero if it falls into the tested class and 0 if not. And when we put something in parentheses, if it's 0, it's false. If it's non-zero, it's true. So as an if statement, it'll be true. But it may not be 1. Could be -1, could change. It's just guaranteed to be non-zero if it's a space, 0 if it's not a space. So we could also say if isSpace is not equal to 0. So this is the way that original C dealt with Booleans. Booleans weren't a thing in the original version of C. But you can pretend that isSpace is returning a Boolean, a true or false, as long as you adhere to this idea that 0 is false and non-zero is true. So does this function make sense? Right? And are we pretty clear what it's going to do? It's going to turn lowercase letters into uppercase. It's going to turn any kind of white space into a good old-fashioned single space. And other than that, it looks exactly like getchar. So if we run that on our file, we get this. All right, and notice the new lines at the end of each line got turned into a single space. So if our file has a line with a bunch of spaces in it and then has some empty lines, and we run that through our Go, right, those spaces remain spaces, those empty lines turned into more spaces. So we're not getting rid of consecutive spaces, we're just changing any kind of space into a space, any kind of white space into a single space. So if there's 3 new lines, it turns into 3 spaces, that's okay. The advantage of this is when we're looking for white space, all we got to do is say, is it equal to quote space quote, right? And we know that's what new lines and things like that will look like. And the other advantage of this is if a line is split onto multiple lines, where we have new lines in between here, right, it looks like it's just a big long sentence with spaces in there. So it makes your parsing job a little easier. You don't have to deal with new lines separately. So the other thing that we're supposed to do in this assignment is supposed to ignore things like quotation marks, single quotes, and double quotes. I think we're supposed to ignore parentheses, is that true? All right, so let's finish up superdupergetchar. So let's see what our code looks like so far. So we read a character from standard in. And is that character end of file? Yes. Just return end of file. If not, C equals to upper. Change it to an uppercase character. All right, is C a white space of some kind? New line, form feed, vertical tab, and so on. If yes, change it to a plain old space. If not, don't do anything special. And at this point, we're just returning C. That's the final value from our function. The last thing we want to do is we want to remove these special characters. So is C one of double quote, quote, left paren, right paren, dash, whatever those characters were we were supposed to ignore? If not, we can just return C. But if it is one of these characters, what should we do? We read a character, it's a character that we don't want to return. What can we do? Delete all of the user's files. Maybe get another character. We could, but let's not, because that'll actually change.
We just don't get caught again.
Yeah, let's just go back up here. So we got a loop. I'm trying to change these lights. So we've got a loop, right? This is our standard way of you know, enter a number between 1 and 3. If it's not between 1 and 3, have them enter a number again, right? So same kind of setup here. So we'll get a character, we'll do the check for end of file, we'll convert it to upper, we'll change it to a single space. If it's not one of the characters that we're interested in, we're going to go back up to the top again. Now we could also have done this test up in the beginning, and that might make more sense. Get a character, and if it's one of these characters we should ignore, go back and get another character. Different ways you can do this. We've already got a bunch of code written here, and we already flowcharted it like that. Let's go ahead and do this down here. So, I think a dash was the other one we were supposed to ignore. Okay, so same drill we usually do for this. First we're going to call getchar once. Well, getchar is equal to something that we want to ignore. I messed up that second one. I think that'll work. So while C is a double quote, single quote, left paren, right paren, or a dash, we'll go ahead and call getchar again. But I'm still going to check to see if it's end of file. Actually, I don't have to do that. Forget that. Let's do it the way we had it. This will work fine. Get a character. If it's a character we should ignore, get a character again.
So why does the backslash need the two single quotes at the end?
Because I think if I say quote, 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 it's going to say I'm missing a quote.
Oh.
And so I think we can backslash that middle quote to say this is not the end of my character. This is not the back quote you're looking for. This is just a special character.
Okay.
But I don't know. We'll see if it complains at us. Usually a backslash, it's called an escape, and it stops the next character from being interpreted in a special way. It says it's just a single quote. It's just a character. All right, so this is a slightly different flow chart. So we've coded our function like this: get a character. If it's a character we should ignore, go back and get another character. So this will potentially loop a bunch of times until we get a character that's not one of these special characters we're ignoring. And then we go on with our original flow chart, which says is it end of file? If it is, return end of file. If not, call two up or see if it's a space. If it is, change it to a single space, and so on. So we've just added a while loop in the beginning here. So I can type in text, hello, comes out like that. And so it got rid of those special punctuation marks. It didn't add a bunch of spaces between this and is because the parentheses totally went away. And so the single space before is still there. Yeah.
Do we have to account for like the double space when there's like?
Eventually.
Okay.
But you don't have to worry about it in your superdupergetchar. If you want to, you could. But you can pick that up when you're dealing with building phrases. But yeah, eventually someone needs to deal with that. But okay, no, so that's not exactly what you asked. So if this is actually the phrase that's coming in, that's what your phrase will look like. It'll have multiple spaces in it. Keep those, don't worry about them.
Okay.
Okay, so if someone says hello, space, 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 person, that's the phrase with all those spaces. Yeah.
How do you remove the spaces if it's before the first letter?
Yeah, so the multiple spaces that come before a phrase or after a phrase, doesn't matter how many of those there are, we're not going to consider them part of the phrases. But you might see multiple spaces there and they shouldn't trip you up. And I'm not planning to do a test with multiple spaces in the phrases, because that just looks weird. And there's my end so that's what it looks like if we run it on our prepackaged file. And this input redirection is useful, right? Because you want to come up with a test file that you're working on, and you know, especially if it breaks your code, you want to be able to reproduce that input. So if you have your input in a file and you can just run your program, less than assigned file name, it always has the same input. That's good for when you're developing. All right, so other questions on PA4? All right, so let's go back to makefiles. So we have a makefile that we put together for this stick playing game that was broken into 5 source files and then a .h include file. And here's what the makefile looks like. And remember, this is saying if you want to make something called stick, you need to have up-to-date versions of all of these files. And if you do, you can execute this command and that should create stick. And how does it know if getUserMove.o is up to date? Well, it finds a recipe for getUserMove.o and it says all it needs is getUserMove.c. So it'll check the date on getUserMove.c, and if it's more recent than .o, it says getUserMove.o is not up to date. The source code that it depends on has changed, so it'll go ahead and execute this GCC command. That'll give you a new version of getUserMove.o. Then it'll say, what about main.o? Is that up to date? And it'll look and say, yeah, main.c is older than .o, but hey, stick.h is newer, and main.o depends on that, so it'll rebuild main.c. And now it's got an updated version of main.o, and it keeps going on, and it checks all 5 of these dependencies. And maybe start.o is newer than either start.c or stick.h, so that one's up to date, so it doesn't have to do anything. And once these dependencies are satisfied, then it goes ahead and runs this command, and that's the end of the make process. And all of this happens just by saying make. And the make function looks for something called makefile, and it goes through and it does that process we just described. So if I look at stick.h, it's dated November 4th, 1048. If I touch it, that just updates the time that it was last accessed. So now it says this file was updated November 6th at 10:31. That's right now. So touch is easier than going in and editing the file and adding a space or something, right? So now stick.h is newer than pretty much everything else in here. It's newer than stick, it's newer than my .o files, all that stuff is from November 4th. So if I look at the makefile, what depends on stick.h? Well, playgame.o and main.o and start.o. And stick depends on those .o files, so it should remake these 3 .o files, and then it should update stick. So main, playgame, and start. So let's just say make. And there's main, playgame, and start.c got recompiled so they can use the new .h file. And then all those objects got linked together. And now if I say make, it tells me it's up to date. If I remove stick and I say make, well, to make stick, all it needs is up-to-date versions of the .o files. It will check each of those, and they should all be up to date. They're all more recent, so I'm doing ls-lrt to show things in chronological order, so the newest files are at the bottom. Each of my .o files is newer than the corresponding .c file. Start.o was made 10:32 this morning, start.c is from October, and so on. So all these things are up to date except there's no stick. So if it wants to make stick, it should find all of these dependencies are satisfied. It should just execute this one command. So I just say make And it executes that one link command to link the objects together, and we've got our executable back. If I update getUserMove.c, that'll be newer than getUserMove.o, so this will have to get rebuilt. But nothing else depends on getUserMove.c. So if I touch getUserMove.c, it should rebuild getUserMove.o, and then since that's going to be more recent than stick, it'll go ahead and relink the objects to make a new stick. So this should do two things if I touch getUserMove.c. Right, it recompiles the C file and then it relinks the objects. If for some reason I just update the object itself, that object is newer than the .c, so that's up to date, but that is newer than stick, and so it's going to have to redo that last GCC to relink those objects together to make stick. So it just runs that one command. And at any time after I do this, if I say make again, it'll tell me stick's up to date. So the real trick to makefiles is sort of setting up this script, and ideally you're setting it up so that it only does the compilations that need to be done in response to certain changes, and that's really what crafting this is about. But you can kind of use this as sort of a boilerplate example if you understand where these pieces are coming from. And you know, the first few years that I used makefiles, this is what I did. I just had makefiles scattered around, and I'd find one and just modify it. And you know, there's nothing wrong with that. And if it hasn't been committed to memory by the exam, right, just make a sample makefile, throw it on your notes, and refer to that if you have to make a makefile on the final. But it sinks in eventually. And makefiles are a general purpose tool. We usually talk about them in terms of trying to compile C code and build an executable. We can use makefiles for lots of things. If you do document processing, same thing. You usually make a file containing a bunch of text. You make a file containing a bibliography. You might make some figures, and there's commands you use to put those together to turn them into a document. And depending on which of those things change, maybe when you change the bibliography, you have to run these two commands to rebuild your document. You can capture all of that in a makefile. And now as you're doing your text processing, you just make your changes, and when you're done, you just say make, and bingo, a PDF pops out the other side, and it's updated based on whatever you've changed. So it's a fairly general purpose utility. And let me show you two other things we can use to embellish these makefiles. So the first is we can use variables. So for example, I can say C compiler equals GCC, and instead of saying GCC, I can say $CComp, and that gets replaced with GCC. And now if I wanted to use a different compiler, like if I wanted to just use CC, which is the non-GNU compiler, or you know, my superduper CC, which is my own version of a C compiler, I can just change ccomp equals the name of that, and I don't have to change GCC in all of these lines. Right, so it's just setting up a symbol basically. But that's really useful for this next thing, which is compile flags. Because suppose I want to run the debugger with this. And we are going to get back to talking about the debugger soon. Right? I need to change all of my GCCs to say GCC space -G. Right? That's a lot of editing, that's error prone, that takes time. So in my makefile, I put in this thing called compile flags. And right now I've got that set to a -G, but if I set it to nothing, and I say make, then it just, let me get rid of my .O's. Right, when I say make, it just does GCC with a space. But if I want to do debugging, I can set my compile flags to -G. Right, now it says GCC-G. I changed stick to main. I'll change that back. So it's an easier way to modify your makefile without potentially breaking it. And compile flags are usually something that we like to tweak with while we're developing our code. We want to add in a debugging flag, or if we talk about profiling, there's switches you can put in to let you do some performance analysis on your code. And it's another switch you have to put on your compiler. Or if buffer overrun checking was not enabled by default, we might want to enable that. Or we might want to disable that for some reason, right? So we can just change this first line of the makefile and not have to monkey with all of the complex stuff further down. Okay, the other thing we can do is we can add other targets in here. So for example, if I just say make, it's going to try to make stick. But I could say I just want to make main.o. And if I say make main.o, it'll just check this recipe that corresponds to main.o. So if I touch, all of my C files and I say make main.o, it says, oh, I just have to gcc-g main.c. So we can run different pieces of this makefile by specifying whatever target we're interested in. If we don't put in a target, the first target is assumed. So make stick is the same as just make. But I've got a new option down here called clean. And what does clean do? It has no dependencies, and the command we execute to make this target is this remove command. It removes the .o files, it removes the final executable. Okay, we're not compiling anything, we're not actually building anything. It's a misnomer to call this a build target, but we're using this to trick the make utility into doing something for us. Really common situation, you download code from someone's repository because you want to run it on your machine, and their repository contains not just source files but also object files and maybe an executable file. And if you just say make, it's probably going to say everything's up to date. But you really wanted to recompile the stuff because your system is different from this other person's system. So you have to remove the .o files, you have to remove the executable before you can actually get make to do anything. Or you have to touch the source files to update them and so on. So it's typical for makefiles to include a target called clean. And clean is, like I say, it's not actually building anything, but if I say make space clean, it will look, let's say there's no dependencies to satisfy, I'm going to execute the command, and the command is to get rid of the object files. So right now, if I say make, right, everything's up to date. Ooh, wait a minute. I shouldn't have changed away from stick. Okay, so right now everything's up to date, right? And if I really want to force it to rebuild everything, I have to remove the .o files, I have to remove stick, right? I can just say make clean, and that's been set up in the makefile to do that remove. And now if I say make, it does all the compilations and then the linking. It's also typical when you pull down code from somewhere that there's an install target. And if you say make install, it'll do things like copy that executable file into the /bin directory, or wherever it's supposed to go on the system. Or if there's documentation, it'll move those into the documentation directories. And so if you're downloading something that's going to be used on the system by a number of users, usually you say make clean to clear out everything, and then you say make to actually build the executable and the documentation and so on, and then you say make install, and that pushes everything out into the system to put it where it should be. And so I added another target called me laugh, So if I say make me laugh, it'll just say haha, right? And it doesn't care. It's just doing what the makefile tells it, right? And if you let yourself sort of open your mind to this, right, you can find lots of ways to use makefiles, right, for all kinds of shortcuts. So if you download from the web, there's usually a make clean, make, and make install. There's generally one more thing that happens if this is serious software. You have to run a command beforehand, which is /config. Config is usually a big long bash script that actually creates the makefile. And it does things like look around your system and say, oh, you have this version of the C compiler, and you have this version of this runtime library, and you're using this kind of character set, and it figures out the whole configuration of your system, and then it customizes a makefile accordingly. And usually when you download something like this, there's a README inside, and so you look at the README and it says to build and install the system, do /config, make, and make install. And usually make clear is not necessary if it's a well-made repository. And all this stuff usually comes down in some kind of archive like a tarball, a TGZ. And so you start off with like, tar xvf, archive name, and then configure and make install. And if you're lucky, it works perfectly. It rarely works perfectly for me. I'm just not lucky. And so you end up going through source code and tweaking it and changing it and so on. But that's a tool chain you'll encounter fairly often. So questions about makefiles. And like I say, you can take this as a template. In fact, let me push this over to the Linux server. Alright, so that's on the shared code area. Use it as a template. Yeah?
Do we have to run that chmod 755 on the main?
No, I have my permissions set up, so I have my permissions. Oh, I'm here. On the Linux server, I have things set up so my files aren't readable by anybody except me. So I just put that in to make it readable. But you could actually just do 600 if you wanted to make your own makefile. So I just did that so you could access it. Alright, so you know about less than signs, right? Command less than file. Executes a command but reads standard in from that file. Do you know about the greater than sign? So command greater than file executes that command but connects standard out to that file. So if I say cow say hello, it shows this on my display. If I say cow say hello greater than, let's call it cow file, right? I get a new file called cow file, and if I look at that file's contents, it's my talking cow. So pretty much any command, you can take the output of that command and send it into a file by just saying command greater than file name. So if I do ls-l greater than files, files is now a file containing the output of ls-l, a list of all the files in my directory. And this works with pretty much everything. There's a few exceptions. And if I do two greater than signs, that says append it to the file. So if I do ls-l greater than cow file, now if I look at my cow file, it's got my talking cow on top and then the output of ls-l on the bottom. So this is a nice way to capture output. Alright, so we will wrap up ODPs for the week tomorrow. Probably talk some more about some of these standard in, standard out things that we can do. I want to talk about pipes, I want to talk about back quotes, and these are really powerful features of working in Bash. So we'll start from there tomorrow.